All right, so in this lecture, I'm going to talk about ggplot, but I'm going to talk about some of the more kind of underlying fundamental aspects of ggplot. In the last lecture, I talked mostly about the qplot function and how you could use the qplot function to kind of make your basic plots, scatter plots, bar charts, things like that. This is in some sense a replacement for the plot function in R, which we use in base plots to create the same kinds of things, scatter plots and histograms. So the qplot function is very handy, but it doesn't reveal a lot of the underlying infrastructure that kind of is built into ggplot that allows you to make all kinds of custom plots. So I just want to highlight a couple of the basic ideas in this lecture. I don't really have time to go over every single little detail of the ggplot package because it's so big. So I thought I would try to get you started on a couple of basic fundamentals. If you have a lot more interest in developing plots using the ggplot framework, there are a lot of references that I mentioned in the previous lecture in terms of the ggplot2 book and other types of books. So I encourage you to look at those resources if you want to explore this type of plotting framework further than what we discuss here in the course. So let's get started. Just to review a little bit in terms of what is ggplot2. Remember, it's an implementation of the grammar of graphics, which was developed by Lee Wilkinson. And the grammar of graphics basically describes an abstract representation for graphics. And so the idea is that it's kind of the verb, noun, adjective for plots. So what are the basic elements that can be modified or cannot be modified, things like that. So it allows for a theory of graphics that you can kind of build on to develop new graphics using this kind of abstract language. So some of the basic components of a ggplot kind of graphic are you need data. Of course, the data is the most important thing. That's what you're going to put onto the page. And so you need to have a data frame that has all the data that you're going to plot in it. You need something that's called an aesthetic mapping. So these describe how the data are mapped to things like colors and sizes and points. Geomes are specific objects that you're going to put onto the page, like things like points or lines or tiles or shapes or whatever you have it. Facets are used for conditional plots. So if you're going to have typically you want to have multiple panels of plots where it might show the relationship of something as a third variable changes. That's a facet. And then stats are statistical transformations like smoothing, binning, quantiles, regression, things like that. Scales are to define how the different variables are coded in terms of the plot. So, for example, you might have a binary variable that represents sex. So the males will be red and the females blue or something like that. And so that is a scaling for a particular type of dichotomous variable. And lastly, you need a coordinate system, which we won't focus on too much on this lecture, but you need a coordinate system that tells you how certain numerical representations get translated onto a plot. So when you build a plot with ggplot2, the basic idea, if you're not going to be using the qplot function, if you want to kind of build it piece by piece, you can kind of think of it as the artist's palette model. So this is similar to the model in the base plotting system, but where you kind of start with something and you kind of add things piece by piece. So unlike the lattice system, where you kind of have the whole plot is encoded in a single function call, you can start with a single call. You can start with the ggplot function, and then you kind of add things on piece by piece, maybe as you think of them, or as you see things in the plot, you make little changes. You can kind of add things here as you go. So the idea is that plots are built up in layers, okay? And so the most fundamental layer, of course, is the data. So the first thing you usually start with is you kind of tell ggplot about the data that you're working with and some basic aesthetics, like if you're making a scatter plot, here are the x and the y variables. Then you might overlay a summary, for example. You might overlay a statistical summary, like a smoother or regression line, something like that. And then on top of that, you might have some metadata or extra annotation for the plot. So the running example that I'm going to use for this lecture I've spoke about previously comes from the mouse allergen and asthma cohort study, which was conducted here in Baltimore. Just very briefly, this is a study that included Baltimore children aged 5 to 17. They all had persistent asthma with an exacerbation in the past year. And we're interested in a lot of the kind of environmental triggers for asthma morbidity in this study. So one of those triggers we're going to look at is indoor air pollution as specified by particulate matter, so fine particulate matter, which is PM2.5, and we'll also look at nitrogen dioxide, NO2. And we want to know whether BMI, or body mass index, modifies the relationship between PM2.5 and asthma. So do children with different BMIs respond differently in terms of their asthma symptoms to exposure to PM2.5. So that's the kind of basic question that we want to answer here. So here's a basic plot. I made this using the ggplot function. You can see the code down there at the bottom. And the basic idea is I plotted the relationship between, I've taken the kind of scientific question in the previous slide and I've translated that into a plot. So I plotted the relationship between nocturnal symptoms here. So these are the number of days in the past 2 weeks where there were symptoms at night, so symptoms while sleeping, for example. And so I plotted the relationship between nocturnal symptoms and the log of the PM2.5 indoor value. And you can see that, roughly speaking, on the left side we have all the normal weight children. And there doesn't seem to be a very strong relationship between log PM2.5 and nocturnal symptoms. And on the right side we have the overweight or obese children, and there seems to be an increasing relationship between PM2.5 and symptoms. And so you can see that there's perhaps some evidence of an interaction between BMI and PM2.5, because the relationship between PM2.5 and symptoms appears to differ by BMI status. So, of course, in order to formalize this, you'd probably want to fit some sort of model, do a little bit more thorough analysis, of course, and adjust for various things. But we're going to stick here with this plot for the moment. So, you can make this plot very easily with the ggplot function and by adding things like facets and geomes to the plot. But I'm going to recreate this plot using the kind of the lower level ggplot framework. And so how do we build this up layer by layer? First we start with the data, right? So here I've got a little excerpt of the data frame, and you can see that there are 3 variables here. There's log BM2.5, there's BMI category, and that's 2 levels, there's normal weight and overweight. And then I have the number of days with nocturnal symptoms, so that's going to be a number between 0 and 14 because it's over the last 2 weeks. And so you can see, so the data are very important in any ggplot graphic because almost everything that you put on the plot can be thought of as some sort of data. And then in the next line here, I've got my initial call to ggplot. You can see I just call ggplot. I give it the data frame, and then I give it a pair of aesthetics. I give it the x and the y variables, which are log PM2.5 and nocturnal symptoms. And then I save this to an object that I call g. And if I call summary on this object, you can see that it shows you what the data are, shows you what the aesthetic mapping is, and it shows you something about faceting, in which case there's no faceting, so that's null. So you can always call summary on a ggplot object, and it'll give you a quick kind of list of what's in this plot and what are the data. Now, the important thing to realize is that I haven't made a plot yet. There's no if you run this code, there will be no picture on your screen yet. So, for example, if here I call ggplot and if I say print g, I immediately get an error because it says there's no layers on this plot. And so, what does that mean? It basically says it doesn't know how to draw the data yet, in the sense that it doesn't know if you want points, it doesn't know if you want lines or tiles or other kinds of polygons or shapes. And so, it doesn't have enough information yet to draw the plot on the screen. So the next line here, I add, so notice I use the plus operator here. So you can literally add things to your plot by using the plus operator. And so when I add the geom_point function, and I save it to a new object called p. So this p object is also a ggplot graphic, but it's got this geom_point thing added to it. Now when I print that out, I get a plot. I get a picture on the screen. So notice that the geom_point function was called with no arguments. I didn't have to tell it about the data. I didn't have to tell it where the points were. I didn't have to tell it anything. So there are a bunch of defaults that will get used. But the point is that the original ggplot object, which is encoded in this g object, has all the information that the geom_point function will need. And so I don't have to separately specify it again. So in this first example here, I saved the modified object to something called p, but you don't have to do that. I could have just said g plus geom_point, and then the plot will have auto-printed to the screen. So you can use auto-printing, or if you want to save the object, you can. So here's the plot, and with the point layer added onto it. So I've reproduced the code down here at the bottom, just for your reference. And you can see that the default for the points are a solid circle, filled circle, and so I used the default because I didn't specify anything different. And so here are the data. Now, another layer that you can add onto your plot is a smoother, and many times you want to do this. just so you can get a sense of the overall trend in the data. So you might want to just get a general sense of as PM 2.5 increases, do we get more nocturnal symptoms? And so on the left-hand side here, this is the code down here at the bottom that I use. I had my original ggplot object, G, which just had the X and Y kind of aesthetics. I added my points to make the scatter plot, and then I added a smooth, the geom smooth function, adds the little smoother, which is the blue line and the gray confidence bands. And so I use the defaults for the geom smooth, which is a low S smoother, which is generally fine, but you can see there's a lot of noise on the boundary. So on the left and right side of the smoother, the confidence intervals get very wide because it's flexible smoother, and there's a lot of noise in the boundaries because there's not much data there. So I'd rather something a little bit simpler than a low S smoother. I just want a linear regression line. And so that's less flexible, but it still gives me a sense of the trend. So here on the right-hand side, you can see I've remade the plot, and I've added the geom smooth, but I give it an option. I said method equals LM, and this will do a linear model instead of a low S smoother. And you can see that on the edges of the linear model, the uncertainty in the confidence bands is a lot smaller than it is for low S. And you see that generally speaking, there seems to be an increasing trend with PM 2.5 and nocturnal symptoms. So another layer we want to add is the facet. So this is the final layer to kind of reproduce that original simple plot that I made with ggplot. So here the facets are going to be determined by the BMI category. So I want to compare children who are normal weight and children who are overweight. So that's going to be two separate plots, but then I want to plot the same relationship in each one of those windows. So that's what creates the facet. And so I can add my facet with the facet underscore grid variable, and this variable uses a special notation which is separate, which has kind of a variable on the left hand side and a variable on the right hand side, and they're separated by this tilde. And so the variables that you specify in the facet function determine how the kind of separate plots are laid out on the screen. And so the number of plots will be equal to the number of levels of your factor. And so if I have two levels in my factor, I've got normal weight and overweight, then that will create two plots for me. If I were to, and so notice that I only have a single a factor variable that I want to separate on. So I'm not going to have a matrix of plots. I'm just going to have a single row of plots. And so I'm only going to have two plots because there's two categories in this BMI variable. If I had two variables, and I'll give an example of that later, so a variable on the left-hand side and the variable on the right-hand side, then the product of the number of factor levels is going to be the number of plots that you generate with the facets. So here I've added the facet grid function, and I also added the smoother with my LM. Notice that it doesn't really matter what kind of order you put these things in. You can add them in at any order you want. I notice I stuck the facet grid function in between the smooth and the point, and that was fine. It still generated the plot. So the facets are useful for kind of conditioning on a categorical variable, and you can see here that the normal weight children don't seem to have any relationship between PM 2.5 and nocturnal symptoms, whereas the overweight children appear to have a much stronger positive relationship. The last thing I'll mention is that you notice that the labels in each of the panels, I didn't actually label them by hand. The labels come from the levels of the factor variable that you conditioned on. So it's important that you use the factor variables in an intelligent way and to have intelligent labels on them, because the ggplot will take that information and automatically apply it to the labeling of your plots. And so in ggplot, in some sense, it's easier to modify your data and make sure that the metadata is specified appropriately, rather than to kind of plot things and then kind of modify the plot later. It's better to make sure all your data is kind of organized and labeled appropriately before you make the plot, because then that makes the plotting code much simpler. Okay, so once you've kind of made your plot, often you want to modify things like the axis labels and the titles and other kinds of kind of plot metadata. And so there are a number of functions for doing that. For the labels, there's the xlab function, the ylab function, and the ggtitle function. Those are all used to specify the X label, the Y label, and the title. You can also use the labs function, which is a more general function that can be used to specify X, Y labels or titles. It doesn't really matter what you use. Each of the geom functions, like the geom points and the geom smooth function, have options that you can specify to change things. So you can explore some of those options too if you don't like the defaults. There are some things that only make sense kind of in a global thing, globally meaning for the whole plot, and so that the theme function is available for that. So this might specify kind of the basic colors, the background colors, or here, for example, the position of the legend. And you can use the theme function to specify these options. And then finally, there are some general themes that are built in that kind of control a lot of different elements of the plot. So you can specify to kind of set many options at once. And basically, the theme _ gray is kind of the default theme, and it gives you the gray background with the white grid lines. The theme BW for black and white is a kind of more stark, a plainer theme if you don't like the gray background. So I'll talk a little bit about kind of modifying some of the features of the aesthetics. So for example, sometimes you might want to change the colors of the points. If you don't like the black points, or if you don't like them to be solid, you want them to be transparent. You can, on the left-hand side, I've modified my basic scatter plot of PM2.5 and nocturnal symptoms by doing two things. One is I've made the color steel blue. I've increased the size of the points to be 4. The default is 1. And I've changed the alpha transparency to be a half rather than solid. And so now you can see that there's blue points that are steel blue. They're somewhat transparent, and they're a lot bigger than they were before. The important thing to realize that I placed these options in the geom_point function, and each one of these options, the color, the size, the alpha, have all been set to be a constant. And so the constants basically are for the are not aesthetics. They're just options for putting the points on the page. On the right hand side here, you can see that the plot looks similar, but there's 2 colors now, and each of the colors corresponds to whether the child is overweight or normal weight. And so now you can see when I call geom_point, rather than say just color equals BMI cat, which would assign the category of BMI to be a different color, I have to wrap it in this AES function, which stands for aesthetics. So now, rather than specify color as a constant, so like steel blue, the color has been assigned to a data variable. And so it's very important that you know the distinction between assigning color to be a constant like black or white or blue, and assigning color to be the value of a variable. So when you assign color to be the value of a variable, what happens is that all the points are split apart, and each set of points is kind of assigned a different color, and then they're put back on the page along with this legend on the right-hand side. But then outside of the AES function, I still have my size equals 4 and my alpha equals 1/2. So those are unchanged from the left-hand plot, so that the points are still bigger and the transparency is still a half. And so it's important. So the key thing to remember here is that there's a difference between assigning a aesthetic value to be a constant and assigning aesthetic to be correspond with a variable, a data variable. If you want it to be a constant, you can just specify it in the geom_point function directly. If you want it to be assigned to a data variable, then you have to wrap it in this AES function. You can modify the labels with the labs function. So the labs function here I've called a few different times. I've added on to my basic plot. So the G object, remember, it's just the data frame plus the X and Y coordinates. Here I've added geom_point function, and I've assigned the color variable to BMI category. So now the 2 different BMI categories are in 2 different colors. The labels, I set the title to be max cohort because that's where the data come from. This is the max study. I've set the X label to be this expression, which is log PM2.5, and I used the mathematical annotation that we talked about previously to get that PM2.5, that 2.5 subscript on there. And then I set the Y label to just be nocturnal symptoms. So now it looks a little bit cleaner. The plot has kind of more appropriate labels on it. I can also customize the smoother if I want to. So now I'm going to modify the options to the geom_smooth function. So here, all I've done is I add an option to say size equals 4. So I made the line a little bit thicker, and I made the line type to be equal 3. So the 3 that just means a dotted line instead of a solid line. I still use method equals LM, so I want a regression line, and I turned off the confidence interval so that's a little bit more clear to see. So I say SE equals false. So these are all options that you can add to the geom_smooth function if you don't like the defaults. So another thing you can do is just change the overall theme. So the default theme, you look in the previous slide here, you can see that there's a gray background with this kind of white grid lines. So there's solid, kind of thicker white lines for kind of larger kind of intervals, and then there's kind of thinner white lines for smaller intervals. If you don't like that background, you can change it to the kind of a more basic black and white background. So this is the theme underscore BW theme. And another thing you can see I've changed here is I've changed the font. So the default font is going to be something like Helvetica, but I've changed it to be a Times font. So now you can see that it's a serif font as opposed to sans serif, and it looks like and it uses the Times font to do the labels, to do the legend, and also the axis tick. So you can see the numbers and the axis are all in the Times font. So the theme function, the various theme functions can be used to modify these elements of the plot. So there's one thing that's worth pointing out, which differs in ggplot than it does from, say, the base plots, is that if you have a plot where the kind of the data kind of exceed the limits of the plot, the behavior between base plot and ggplot can change a little bit. So here on the left-hand side, I've just simulated some data. So this is not max data. And I've intentionally introduced a little outlier here. So in the 50th data point, I've just changed that value to be 100. So now there's kind of this random series of noisy data, and then right in the middle there's a point that's 100. And so if I call plot, so I'm going to make a standard base plot here. I call plot on x and y, and I say type equals L because I want to make a line plot. But then typically, if you have some outlier like this, maybe you don't want to look at the outlier. You just want to look at the core of the data. So it's typical to kind of set the y-axis limits to be roughly kind of where the data are, and then just ignore the outlier. So you can see that the time series that gets drawn has all the data connected, and then you can see roughly where it's going to shoot off to 100, and then it comes back down to be roughly where it's supposed to be. So you know that outlier is out there somewhere, but you don't see it in the plot. Now, if I do the equivalent plot in ggplot, I can create my ggplot with the test data and the aesthetics to be x and y, and then I add the geom_line function to make a line plot as opposed to a scatter plot. You can see that it just plots all the data, including the outliers, and it's maybe not exactly the kind of plot you want to make because the outlier is maybe not that interesting. So if you want to do this, you have to be careful about how you do it. And so the first is that on the left-hand side, you might think, well, I'll just change the y limits to be within kind of in the range of most of the data between -3 and 3. The issue here is that what ggplot will do is it will subset the data to include the values that are between -3 and 3. And so of course the outlier is not included in this data set, and so you won't see that data point in this plot. So you can see this clearly where the outlier is missing, the lines are not connected, but then everything else is connected afterwards. So if you want to recreate the kind of phenomenon that you saw with the base plot, you have to add this special function called coord_Cartesian, which sets the limits to be -3, the y-axis limits to be -3 and 3. And you can see in the plot here that the outlier is in fact included in the data set. The data set hasn't been subsetted to only include the ones that are in the y-axis range. So I just want to go over a slightly more complex example of kind of adding pieces to a plot, just so you can get a sense of how the different layers are added on, and then hopefully get you going from there. So here I've made the scientific question just a little bit more complex. I want to know, how does the relationship between PM2.5 and nocturnal symptoms vary by both BMI and nitrogen dioxide, or NO2. And so as NO2 or BMI values change, what does the relationship between PM2.5 and nocturnal symptoms look like? So one tricky thing about this is that unlike our previous BMI variable, which is categorized into kind of normal and overweight, the NO2 variable is continuous, or it's really the log of the NO2, and it's a continuous variable. So we can't really condition on a continuous variable when we're making plots, because then there would be an infinite number of plots. And so we need to categorize this variable into a reasonable series of ranges. And so what we're going to do is we can use the cut function for this purpose to literally cut the data into a series of ranges. So here's some code to make NO2, to split NO2 into tertiles. So this is going to be 3 separate categories, kind of between the minimum and the 33rd percentile, the 33rd to the 66th, then the 66th to the maximum. And so the first thing I need to do is to use the quantile function to figure out where in the data ranges are the 33rd and the 66th percentiles. Then once I've used the quantile function to find these cut points, I pass that to the cut function, and I use the cut function to actually cut NO2 into these 3 different ranges. And so what the cut function does is it just returns a factor variable where each of the original data points is replaced by its category in terms of which tertile it's in, so in terms of the low, the middle, or the high tertile. So it's a very handy function for when you're using things like lattice or ggplot and you have to categorize continuous variables. So now you can see the levels of this variable. The cut variable there's 3 different levels, just kind of 0.378 to 1.2, 1.2 to 1.42, and then 1.42 to 2.55. So those are the 3 categories that I've split the NO2 variable into. So here's the final plot. I'll just show you what I'm going for, and then we'll work backwards to figure out exactly how to do it. So you can see that there's 8 different plots here. On the top, you see all the normal weight children, and on the bottom, you see all the overweight children. So those are the 2 categories of BMI. And then there's actually 4 categories of NO2. There's the first tertile on the left side, the second tertile in the second column, the third tertile in the third column, and then there's actually some data that are missing. And so these are the data that are missing NO2 values, but they're not missing all other values, so you can still in some sense plot them. And so it's often important to look at the missing data just to see if there's anything special about those missing. You don't always just want to exclude them right off the bat, because there may be something special about them that you've missed. So what does this plot have? Well, first of all, I've modified the transparency on the points, so I've made them a little bit transparent so you can see a little bit of the density there. I've added a smoother to each panel, so this is a linear regression smoother, so it's not the default, and I've turned off the confidence bands. There are multiple panels, so I've used faceting to create this plot. I've changed the kind of default labels and the titles, so I've added to reflect, kind of be a little bit more descriptive. And then finally, I used a non-default font. So the default font is Helvetica, and I've changed the font here to be Avenir. And so there are a number of options that I've modified here. And so here's the code for doing it. So in the first set of code, I just call ggplot, I give it the data, and I give it some basic aesthetics in terms of the x and y variables. And then to this g object, I add a bunch of things. I add points using geom_point. I make the panel using the facet wrap function. And then I add a smoother using the geom_smooth, where I specify the LM method, and I turn off the standard error bars. I changed the theme to be this black and white theme, and then I modified the font to be Avenir instead of the default. And I've also made the font a little bit smaller to be 10 points instead of the default 12. And then finally, I've called the labs function 3 different times to change the labels: the X label, the Y label, and the title of the plot. So you can see that I've added all these different things piece by piece to make this plot a little bit more and more interesting every single time. And it's easy to do this with ggplot. And the nice thing about ggplot, which I didn't do here, is that you could in fact save this to a new object, and then you would have everything stored in a single R object. And then if you wanted to add in more layers, you could add to that new object. You could continue to add different things if you wanted to. So it's a very modular, very kind of useful framework for constructing plots that are new just for your data. So just to summarize very quickly, I know this has been a very brief introduction to ggplot, and there's a lot of things that you could talk about, but given that this is not a course specifically on ggplot, I thought my hope was to kind of get you started, to get you typing in some basic code, making some basic plots, and then if you want to know more, you can kind of look at some of the references that I mentioned previously. So I think in summary, ggplot is very powerful, it's very flexible if you can learn the grammar and learn the different pieces that you can add to a plot. And that can be tuned and modified. There are a lot of different types of plots you can make. I've left out a lot, but you can explore and mess around. I think that's kind of the best way to learn about these things, and to take a look at some of the references that I mentioned in part 1.